Muted.
So welcome back. So this is the fourth session of your core Java basics. Okay. So let's see what, as usual, we will see what we have done or recap our previous class session, and then we move on to what we are going to cover for today's session. Okay. So today's session will be a bit shorter. Okay, and we will wind up very early today. Can everyone hear me clearly? Am I audible? Okay. Let's see what we did in our last session. Okay, let's start with that. So we got introduced to different number systems. Apart from the number system we are all familiar, that is the decimal number system. And apart from decimal number system, we got introduced to binary, octal, and hexadecimal system. Okay, so in that I gave one exercise like how to convert any other binary system, I mean any other number system, that is binary, octal, hexadecimal, to the decimal number system. Did anyone do that exercise, or at least try to see what exactly or how exactly we can do it? Did anyone try? Okay, yeah, looks like a few people have tried it. Good, yeah, yeah. I've got a question. Let me unmute you. Yeah, please go ahead and ask the question.
No, I didn't have a question.
Oh.
I just said that I did that assignment.
Sure. Okay, if you can take off that hand, right, that would be great.
Okay, yeah, sure. Because
yeah, thank you.
That
yeah,
I did that because, but I was unable to mute my laptop, so I just hand raised.
okay.
Okay. Thank you.
Okay, no worries. Yeah. Yeah. Then we moved on to the like high level. We saw a high level overview of operating systems, and then we tried to understand what exactly is a JDK and why we need JDK, and we saw steps to install the JDK. Okay, that was for Windows, and as I told you, I will provide you the screenshots or a document for all the operating systems. One is Windows, Windows 7, Windows 8, if possible Windows 10 as well, and Linux, and then if I get hold of Mac OS X, I'll try to provide those that document as well. Okay, that document will have all the information like how to, which link to go, downloading, and how to set the path. So yesterday someone was trying to ask like how to set the path. He was not able to set the path variables in Mac OS X. Okay, so those things I'll try to include as much information as possible. Okay, also we got introduced to what is known as integrated development environments. Okay, so the one which we would be using in our training session is the Eclipse. Okay, there are other, as we discussed yesterday, there are other IDEs also. The most familiar one is the NetBeans, and Java's, Oracle's their own IDE, that is JDeveloper. Okay, and we saw a simple Java program in a traditional way by seeing by writing a simple Java program which says hello world. Okay, so we try to understand few keywords that are public, class, and static. We haven't introduced anything related to static yet, and then void, that is the return type of a method, and we also try to understand what exactly is the method. All right, so let's see what we've got for today's class. Okay, we'll try to understand with a basic question, that is what is a programming language. Okay, then we move on to the JVM part, which is nothing but a Java virtual machine. Okay, so we will try to understand a bit Okay, like what exactly is a Java virtual machine and why do we need Java virtual machine? And in tomorrow's class, we'll just briefly go through the architecture of Java virtual machine before getting into the basics of Java. Okay, then we will see what is the difference between executable code and byte code, and see just a simple flow of how the byte code gets converted into whatever that is needed for the execution of Java application or Java program. Okay, so let's move on to the programming language. So what is a programming language? So let us try to answer this with the familiar thing that we know. Okay, the thing that we know is language, right? So what is a language? Okay, so it is, as we all know, it's a communication channel, right? So it can be either spoken or it can be written. Okay, why do we use that? We use it to communicate with other people, with other humans. Okay, in rare occasions, we can communicate with the animals also or pets also. We'll put that aside. Okay, so but here we are talking about humans. So we use a language. There are thousands of languages around the world. So we use different kinds of language to communicate with each other, basically to humans, right? So when we use this language, right, we simply don't speak whatever comes to our mind, right? Whatever I am telling or whatever I am speaking right now, that is the use of words in a structured way or in a conventional way. I can't use like a language, what is, I can't speak like that, right? We should know how to speak, okay, a language. So it should be a structured one. Otherwise, it doesn't make any sense, right? So we use words in a structured way to form sentences, to communicate our ideas, to express ourselves to other humans, right? Similarly, what we do using a programming language is, you can consider programming language also as a communication channel. But the difference here is we communicate or we try to talk to a machine instead of a human being. Got it? Yeah, the only difference is we try to talk to a machine using the language which it understands or the language which we understand and use some other tools to convert it into a language which machine understands. Hope you are all getting what I'm trying to tell, right? And I'm going a little slow because I want all of you to listen to me and then at the same time think about it and understand it, okay? Okay, so that is what the language is. The programming language is designed to communicate with the machine. Okay, how do we communicate with the machine? We write instructions similar to the sentences that we speak with the use of words in a structured manner, right, when we communicate with humans. Okay, so what we do with this programming language, we write instructions to communicate with machines. Okay, not any machine, but computer particularly in our context. Okay, so using programming language, what we do, we create programs. Okay, we create programs to control the behavior of a computer machine. Control the behavior of a computer machine is nothing but like you write instructions, okay, to make the computer do what you want to do, right? Say for example, you want to add two numbers, you write a set of instructions or sequence of instructions. When you execute that, internally the computer will execute it and it gives you the result, right? Using your logic, whatever the logic you have written it. Okay, so let's move on to the Java programming language. So by now we all know that Java is a high level programming language, right? Because it uses when we write program with Java, it will look like similar to our English. Okay, so like when you go through the program, you'll be easily able to, you can easily kind of like relate to what you are trying to speak within that program. Okay, that is why it's a high level programming language. So as we know, whatever the instructions that we write with the high level programming language, that gets converted into what is called as machine level language, or the language that a particular machine can understand. Okay, which is nothing but zeros and ones. Okay, which a computer can understand. Let's move on to the next slide. So let's see what is a Java virtual machine and why do we need Java virtual machine. Okay, so before Java came into picture, there were other popular high-level languages, which I covered in my next slide as well. Okay, other popular high-level languages. They are like wherever you go, you might have heard of C and C++. Okay, in your academic or in your as whenever you hear about high-level languages, right? Before Java, you would have heard of C and C++. Okay, those are the very famous. Still, they are famous for, but Java kind of like overtook it. They are the very famous high-level programming languages that were used before Java came into picture. So when you that also uses kind of like similar to whatever the English words that we use to write our instructions in Java, or to in fact C and C++ is used to write or to build Java program itself. Okay, because of that one, whatever if you know C and C++, it will be easier for you to understand Java. Okay, because same set of probably same set or same subset of keywords plus additional keywords are used in the Java programming language. Okay, so what I was telling is, say for example you write a program in C or C++. Okay, so if you want to run that program, what we have to do, you have to compile that program using a software or a program called compiler. Okay, you use a compiler to compile the program that is written in C, C++. Okay, not only this one, any high-level language uses their own compiler. What that compiler does is, it takes the source file. Okay, it takes a source file and converts or translates it into a executable code. Okay, it converts or translates it into a executable code. Okay, executable in what? Executable in a machine, right? Executable in a machine means executable in a particular process which is being used on particular computer or system, right? That executes your instructions, or the executable code which was generated by the compiler for the language or the high-level language which is used for writing that particular program. Okay, hope you are getting whatever I'm telling. So we write a program in any high-level language, for example C or C++. We use a compiler to compile that program, which generates us executable code, which is nothing but a machine code. Okay, by now we know what is a machine code, right? Which is a string of zeros and ones, which a particular processor or CPU or computer or machine can understand. Okay, understand or execute it. It can interpret that executable code or machine code and give you the result for whatever you have written. Okay, but this machine code that is your executable code. That executable code is specific to that machine or the computer or the platform, hardware and software platform. Okay, you know what does that mean, right? Machine code is nothing but your machine specific instructions, right? We know from our microprocessor class, we know that machine code is specific to particular microprocessor. Okay, you may have your own Intel microprocessor. For that, you'll have a separate set of machine code or separate set of instructions associated to that particular processor, or you'll have AMD processor. That AMD processor will have its own set of machine instructions or machine language associated with that particular processor. That again depends on the version of your microprocessor. Okay, say for example i7, i5, i3. Okay, they are just enhancements. You'll see more instruction set as you go upwards and less as you go downwards. Okay, so this whatever the executable code that is generated, okay, out of your compiler, for example, so for C and C++, they are machine dependent. Why? Because we are directly converting the source file into machine code. Okay, that machine code or executable code is generated to run that code on that particular machine or platform, hardware and software platform. For example, you have written a C program in your Unix machine for say for example i7 64-bit processor. Okay, machine code that is generated is specific to that particular processor and operating system. Okay, so it is tied to that particular operating system and the processor. You can't run the same executable, you can't take that executable code and run it in some other machine. Okay, for example, you can't take that same executable code and run in your Windows program, under Windows operating system. For that matter, the different version of Unix, you can't run the same code in different version of Unix. For example, you have written a code in Linux and compiled it. You take this thing, so executable code, and then we call it as object code, okay, OBJ files. So you can't take out that executable code and run it in your Mac OS X. Okay, so what I'm trying to drive, which point I'm trying to drive here is, those are machine dependent. Okay, those are specific to that machine. Okay, that executable code that is generated. So let's move on to why Java was designed and developed. Okay, so in order to avoid those kinds of restrictions like platform dependency, machine dependency, Java was designed and built, okay, to bring the platform independency to a particular language. Okay, the design goal was write once and run anywhere. For that matter, for example, say you have 64-bit processor and Windows 7 operating system. Okay, you write a Java program. Obviously, you have to, for developing your Java program, you have to use JDK, which is 64-bit JDK, right? So you develop a Java program, for example, that simple hello world, and compile it. When you compile, we know that it generates a dot class file, okay, and then you take the dot class file and put it in a Unix environment which has i7 or 64-bit JVM or JRE. If you copy this particular class file in a Unix environment which has a 64-bit JVM, we can run the same file which was written using Windows operating system in Linux operating system. Okay, we will see how that is achieved. So the core of this platform independence comes with what is known as Java virtual machine. Okay, so as you can guess, it is a virtual machine. Okay, as the name itself says, it is a virtual machine, not a physical machine. When I say a physical machine, it is a processor, okay, or a CPU. You can say it's a CPU or a processor, okay. Actual machine or physical machine is your processor, okay. Virtual machine is something which is not actual machine. You can consider that as a kind of software which actually performs the operations of your processor, that is a hardware. Okay, for example, you have some set of operations that you can do with your processor. Okay, memory management, okay, your file management, all those things. Okay, maybe not all the functionalities of a particular physical processor may not be implemented in JVM, but whatever is needed for the execution, for providing the Java runtime environment, all those things are implemented in that particular JVM. Okay, so you have two things, right? You have a Java source files. Okay, using an editor, you write a Java source file, and you save that with the extension .java. Okay, like we have .doc.docx or .txt, the other files, right? Other type of files. Similar to that one, we use an editor which we saw like Eclipse, and then it automatically saves your files in .java file. But if you are using other than Eclipse, like I did for example, Notepad, we use .java extension as the Java extension for saving the Java code. Okay, so what you do, as we did in C++, we use a compiler to compile this Java source code. Okay, but there is a major difference between what gets generated with Java versus what gets generated with C or C++ type of languages. Okay, so in C++, we know it gets, we get a executable code, which is like, which you can directly execute on a platform where you have written that program. Okay, but in Java, it generates what is called as .class file, which will have byte codes. Okay, these byte codes are like these byte codes can be understood by only by the JVM. Okay, only by the JVM. So these byte codes are similar to your machine code for your physical processor. Okay, this byte code is similar to the machine language for your physical microprocessor. Okay, similar in the sense this byte code is similar. This byte code can be executable by this virtual machine, like the way the machine code gets executed in your physical processor. That is why it is called as virtual machine. Can you all hear me clearly? Okay, someone told they can't hear me. So please, can you please check whether you have muted yourself, or your volume is not proper or so. Okay, yeah, thanks. Yeah, so did you understand the concept of JVM? Okay, so let me explain that again. Okay, few people have understood and few people have not understood it clearly. Okay, so let me understand it. Yeah, let me understand. Let me repeat that same thing again. Okay, let me start from C, C++. Okay, uh, okay. So how many of you understand the machine language and the processor? What a processor does and what is machine language in relation to a processor? Microprocessor. We are talking about microprocessor. How many of you know? Okay, so processor is nothing but, as the name itself suggests, okay, it processes something, okay, it processes something or it executes some instruction given to it in a language which it can understand, okay. That language which a processor can understand is the machine language, okay. The microprocessor can understand a language called machine language, okay. So we understand, we are speaking a language which we all know, that is our English, right? So English is made up of what? English is made up of 24 letters, right? Using those 24 letters, you make words. Using those words, you construct structured sentences to communicate what you want to do, what you want to express, right? Similar way, machine language is made up of zeros and ones, okay. That is binary digits, zeros and ones, okay. Using those zeros and ones, you can make a word similar to the words that we use in English, okay. Those words are dependent on the processor. For example, we discussed about an Intel processor which is of 8-bit, that is 8085, right? For 8085, if you give a 8-bit word, okay, I am telling 8-bit word. Why 8-bit word? It is because 8085 can process 8 bits at a time, okay. That is why it is called 8-bit processor, okay. So for 8085 microprocessor, 8 bits is a word, okay. So when we write a program is nothing but you use those words, that is 8 bits, and construct a set of you in English you use your words, that is you using your letters you construct your words, and using words you form a sentence, right? Similar to that one, using 8 bits you construct or you write a set of instructions which can be executed by the microprocessor, okay. We are in the world of i7, Intel i7 processors now, right? That is a 64-bit microprocessor. So it can process 64 bits at a time. That is why it is called as 64-bit microprocessor. So the word for a 64-bit microprocessor i7 is 64-bit, okay. So that is the relationship between the machine language and the microprocessor. Like we have English for humans, right? Machine language is for the microprocessor or the machines for that matter, okay. Similarly, when you see the code that is directly written in machine language, it will be like zeros and ones, zeros and ones, zeros and ones and zeros and ones. You won't be able to make out anything out of that zeros and ones. That is why people came up with something known as assembly language, okay, where they use English-like words which are called as mnemonics, Okay, so using mnemonics, we write code in assembly language, which again gets converted into machine language, because machine language is the only language which a computer can understand or a processor can understand. Okay, using something called as assemblers. Okay, but that was also difficult to understand. Okay, so people came up with something known as high-level languages, which uses English-like words for writing programs. Okay, Java is one such high-level language. Other examples would be C and C++. Okay, but before Java came into picture, how things were. Okay, I'll explain. We write programs in high-level languages, say for example C and C++. Okay, but as I told you, processor or machine can understand only machine language. Okay, that is, your computer can understand only machine language, which is made up of zeros and ones. Okay, so what you have to do, you have to convert the program that is written in your high-level language using English words. Okay, they are called keywords, using English-like words into something which a machine can understand. Okay, for example, say for example, I will write 10001 or something in ones and zeros and give it to you. Will you be able to understand that? As a human being, we will not be able to understand that. Okay, we need a way to convert that zeros and ones into things which we can understand, right? For example, you are seeing all these words and diagrams, right? Java Virtual Machine, JVM and all. Underneath, they are all zeros and ones to the computer, which is understood by the computer, but that is presented to us in a way that we can understand, right? So whatever the program that we have written in our high-level language needs to be converted into your machine language, which is low-level language. So we use something called as compilers. Okay, which actually compiles your code into something known as executable code to execute the program. Without compiling, you can't run a program which is written in high-level language. Why? Because to execute a program, you have to convert it into zeros and ones. Okay, that is achieved using a software called compilers, because machines can understand only zeros and ones. Okay, I might be repeating the same words again and again, same sentences again and again, because I want all of you to understand what we are discussing in this class. Okay, that is why. So when we compile a program written in C or C++ or any other high-level language, okay, that gets compiled into an executable code, which is nothing but your machine code. Okay, which you can directly run on your hardware or processor, physical machine. Okay, processor or CPU or computer, we generalize it as physical machine. Okay, means you run means that processor takes the set of instructions or sequence of instructions that you have written, okay, which is converted into set of instructions that a computer can understand in machine language. Okay, it reads one by one and executes it. Okay, it gives us the response, which is again in zeros and ones, which gets converted into the form which humans can understand. Okay, be it image, be it words, or whatever it is. Okay, but as the executable code is generated for that particular software and hardware platform, it is specific to that particular platform, be it hardware or software. When we say software, it is operating system. Okay. For example, you have written a program for your Windows operating system on your Windows operating system. Okay, for some processor XYZ processor. Okay, when you compile that particular C or C++ program, the object code or the executable code that is generated, okay, is specific to this particular platform, that is Windows and XYZ processor, because that particular processor, right, that will have its own machine language, which is nothing but a set of symbols with zeros and ones, like words, okay, which that particular processor can understand. Okay, so this is what is called as platform dependency. Okay, that was creating a lot of issues. For example, when you write a program for programs on Windows, with you can't take that particular executable file and run it in Unix operating system with the same processor, with same other hardware configuration except for operating system. Okay, you won't be able to run it. You have to run the same program again, or you have to write the same program again in Unix for the processor, again compile it. So when you get the executable code from Unix to Windows, that again will not run. Okay, that is what is called as platform dependency. Okay, to a particular hardware and to your OS. So that particular executable code which is generated is tied to your hardware and software platform. Okay, so people wanted to get out of that particular platform dependency. Okay, that is when they thought of designing and developing Java. Okay, so the main goal for designing this Java is write once and run anywhere. Means you write the code once. Okay, you write the code once and you can execute it in any other operating system. Okay, but we will see this also has its own dependencies. Okay, I'll tell you what exactly is that dependency. Okay, so how do we achieve this platform independency in Java? That is using what is called as Java virtual machine. Okay, we are talking about virtual machines here, not real machines. Okay, virtual machines. Real machines is your hardware, that is your processor, actual physical processor. Okay, but Java developers or Java creators have created a virtual machine which can execute or which can understand its own machine language. You can call it as machine language. Okay, which is nothing but bytecode. Okay, you can assume this bytecode as the machine language of the Java virtual machine. Okay, like we have machine language for physical machines. Okay, how do we get this bytecode? We have to write source files, that is Java source files, using some editor like we did in our last class, Eclipse, right? We used Eclipse editor or IDE, which includes not only editor, the other tools also will be there. Okay, use any editor to write a Java program using Java syntax, okay, and then compile it using a compiler. Okay, as I told you, why do we need a compiler? We need a compiler to generate a code which a particular machine can understand. Okay, so here when you write C++ program and compile it, there is no intermediate level between the code or the executable code that gets generated when you compile it. Okay, whatever the code that you generate out of C++ code after compilation, that the output of that compilation can be executed directly in your processor or in your machine. That is why it is platform dependent. Okay, but in case of Java, there is an intermediate level. Okay, that intermediate level is nothing but your bytecode. Okay, your bytecode is nothing but set of, you can assume like it is a set of zeros and ones. If you open, you can open a dot class file and see what exactly is there in the dot class file, but you'll not be able to, you can see zeros and ones, but you'll not be able to understand anything, which can be understood only by your Java virtual machine. You can assume like it is a software which has the capabilities of your physical properties. May not be all the capabilities, but most of the capabilities of physical processor. Okay, that is why it is called as virtual machine for Java virtual machine. What do you mean by modifiable? If you corrupt your dot class files that is generated, you'll not be able to run, obviously, because something would have gone wrong, which JVM cannot execute. So this is the question, okay, for everyone. So one person is asking, is a dot class file modifiable once it is generated? Okay, Java class can be modifiable. Okay, you take one Java class, modify it. Yesterday, like we did it, right? Java, I mean the Java program can be modifiable, but the generated class file you can open and modify and save it. You can do that, but by doing so, you are corrupting the generated class file. Okay, when you try to run that corrupted file, you might get errors. You might not be able to, you might not get the result what you are expecting when you run it under in Java JVM. Okay, so what is a JVM? It executes the bytecode instructions. Okay, or whatever that you write in your Java. Hope I answered your question. If so, please confirm yes or no. Okay, yeah, so that's great. Yeah, so whatever the generated code, that bytecode gets executed in your JVM, right? But this JVM acts as an interface between your actual physical machine and your operating system. Okay, your operating system is the one in which your JVM is running. Okay, on top of your operating system, JVM will be running. Okay, JVM makes, whenever you write some program, when the JVM executes, the JVM, what JVM does is it interprets each and every instructions that you have written using Java program and converts it into machine code. Again, why? Because that actual execution takes place in the physical processor, but your bytecode will be executed by JVM, which in turn converts or interprets your bytecode or compiles it into a machine code, which can be executable by your physical processor. Okay? Did all of you understood what I told or what we discussed just now? Yeah. Okay, cool. Yeah, let's go to the next slide. So where we see, like, I've just given this executable code and bytecode. So by now you know that executable code directly executes on your physical machine, right? It executes directly in your physical machine because that executable code is nothing but a sequence of zeros and ones. Okay, sequence of zeros and ones, which a particular machine can execute. That is why it is platform dependent. Okay, but bytecode is executed in your virtual machine, which interprets your instructions in bytecode and converts it into corresponding machine language code. Okay, that is why, because of this interface, if we can call it that way, interface between your physical machine and the program that you are executing, Java is platform independent. Okay, Java is platform independent. When we saw in our last class while installing JDK, we saw so many versions of JDK, right? Specific to one version of your operating system. For example, JDK for 64-bit Windows operating system, right? JDK for 32-bit Windows operating system. JDK for 64-bit Mac OS X operating system. Okay, JDK for Solaris, JDK for your Linux, which again was 64-bit and 32 bits. Okay, here I would like to mention one important thing, that is JVM is platform dependent. Okay, note the point, JVM is platform dependent. Okay, but not the code, Java code which is written. Okay, you can write a program for one particular JVM and run it in anywhere. That is what is the concept behind write once and run anywhere. Okay, let's move on to the next slide. So here we see like how that bytecode gets executed. Okay, yes, we have written. Yeah, one person is asking, is JVM machine dependent? Yes, exactly. It is machine dependent. What exactly it does is, it takes your bytecode and converts that bytecode into machine code. Okay, machine code, but converts that bytecode into machine code, which a particular machine can understand. That is why Java creators have come up with this particular concept, that is Java virtual machine. That is why people develop JVM for particular platforms to that particular machines. Are you getting my point? JVM is nothing but your Java runtime environment or JDK. JDK is a superset of your Java JRE. Okay. So one person is asking a question, that is, if you want to modify a code after delivery, or if once the code is in production, how can we modify that code? You are writing a code for a particular client, right? You're not going to change the systems for the particular client. For example, today you have a production system which is Unix-based operating system, or Unix-based system, right? Tomorrow you can't change it to Windows system. Do you change it? No, right? Even if you change it, the same, whatever the code that you write in your Java, right? You deploy it in different formats. That is, simple standalone Java programs or Java programs with UI that is developed using something called as strings. You deploy it using some format called .jar files. Okay, and in case of web applications, .war files or .ear files, enterprise archive files. Okay, if you have that one, you can deploy it in anywhere, irrespective of your operating system. But provided you should have corresponding version of JVM running in that particular machine to run your .class files or your bytecode. Okay, one more question is there. So JVM generates a machine code for Unix. It cannot understand by Windows. So what if I understand correctly? So what the question is? So the bytecode is JVM generates. Say for example, I have a JVM which is running in Unix operating system. Okay, it generates a bytecode. That is your .class file. You compile it and generate a .class file. And the question is whether we can run the .class file on Windows. We can run the .class file on Windows, provided you have corresponding JVM, which is implemented for Windows. Hope I answered the question regarding Windows and Unix. If you can confirm, that would be great. Okay, cool. Yeah, there is one more question. What is the main difference between JVM and JDK? Okay, so as I told, JDK provides an environment for development. Okay, as the name suggests. Okay, development kit. It is a development kit. Okay, it includes the tools that is needed for your Java development, for writing your programs. Okay, for compiling you'll have your compilers. For running you'll have your Java loader. Okay, the one which we discussed yesterday. Okay, and for other things you will have other tools. Okay, that is your development kit. Okay, but JVM, which is, if you can see this diagram, right, the figure which or the screen on the screen, Java virtual machine is a part of your runtime environment. Okay, for running a developed Java application, you need not have to have your JDK installed on that particular machine. If you just have Java runtime environment, okay, if you just have Java runtime environment, that is sufficient. Okay, so JDK is a superset. JDK includes JRE. Okay, when you develop a Java program, you need to compile it, which generates your .class file. Once you compile it, what you will do it? You have to run it, right? For running a Java program or the .class file which is generated from your Java program, you need a JRE, the runtime environment, which is at the core of JRE is nothing but your Java virtual machine. Okay, you need JRE to run your Java programs or compiled Java code. Okay, did I answer your question? In simple terms, you can say like JDK is a superset or JRE is a part of your JDK which is used to run your compiled Java code using JVM. Yeah. Okay. One more question is there. Can you please tell me the difference between machine dependent and platform dependent? Platform is nothing but it's a combination of your hardware as well as your software. Software is nothing but your operating system. Okay. Machine dependence means that only. Okay. Your operating system in turn, say for example, you have written C++ program. Okay, on your Windows. Okay, on your Windows. When you will obviously you will have a compiler for that particular Windows. Okay, which is using your operating system as a medium to generate your machine code. Okay, your machine code which is using your operating system that is operating like the compiler is what does a compiler do? It generates your executable code or machine code, right? How does it generate machine code? It has to understand the underlying hardware, right? So what does a particular think about it? What about a particular operating system does? Okay, so it will have its own firmware, or it will have its own device drivers, or it will have its what we call it as system calls. Okay, system calls. Using those system calls, it directly interacts with your hardware resources, whatever it may be. Okay, one of that resource is your CPU. Okay, how does a CPU executes a or an instruction? How does it execute an instruction? It understands its own language, which is called as machine language. Okay, so the operating system, how does the operating system generates or the compiler generates executable code? It uses your operating system as a medium to go through or understand the architecture of your processor or the language that a particular processor understands. Okay, it has to go through operating system to what I'm telling is the compiler has to go through, because the compiler is running on your operating system. It has to go through your operating system to understand your computer hardware, or you can say your compiler is written for the operating system on which it is running, for the hardware on which the operating system is running. Did I make it clear? I guess you still have a doubt. Is it fine? Okay, so that is where you see, whenever you see a platform, it is nothing but your hardware as well as your operating system. When I say software, it is a operating system. The compiler is specific to that particular operating system and that particular processor. That is why we say that it is a they are for C and C++, they are tightly coupled with your machine language. Okay, machine. They are platform dependent. Yes, exactly. Not all the operating systems. So one more question is, does all the operating system have different JVM? Obviously, we saw not all the operating system. It depends on your processor, right? For 32, say for example, we take Windows itself. Okay, somebody might be having Windows 95 or some older version of Windows than Windows 7. Okay, maybe that is running on your 32-bit microprocessor, Intel microprocessor. Okay, you should download JDK or JRE for 32-bit microprocessor or for 32-bit operating system. Okay. But assume I am using Windows, which is Windows 7, which is 64-bit operating system. Windows 7 also comes in 32-bit operating, 32-bit also, I guess. When you are using 32-bit Windows 7, you have to download JDK or JRE, which is 32-bit JDK or JRE. Okay. For 64-bit Windows 7, you have to download 64-bit JRE or JVM. Okay. So that knows how to convert your dart class into respective underlying hardware platform. Okay. That knows, because vendors know how to implement JVM for that particular hardware, 32-bit or 64-bit. The same thing applies to your Linux or your Mac OS X. Mac OS X is nothing but a customized version of Apple's customized version of your Unix. Okay. Yeah, I think you have to go through the session. I mean, one more person is asking, did I miss much? I just joined. So you are too early for tomorrow's class, I would say. We are winding up our today's class. But anyway, we will share the session video recording, right? You can go through that video recording. If you have any doubts, you can come back to us. Okay, you can ask that question in our next class, or you can send out an email. Okay, yurashtakur@gmail.com. So from our directory would have got an email, right? You can respond back to him asking your questions. Okay. Okay. So let's. I mean, if you can see this, whatever I have explained, the same thing has been shown in this particular diagram. Okay. So whatever the code that gets generated out of your Java virtual machine has to go through your operating system to reach your hardware. Okay. So that is how JVM, which is a part of your JRE, makes your Java code platform independent. Okay. With this note, let us go to next slide. Okay, so which is nothing but our question and answer time. Hope I've answered most of your questions. If you still have any doubts regarding what is JVM, platform dependency, platform independency, or how do we achieve platform independency through JVM, please send out an email. We will make sure that we will try to answer your questions. Okay. Okay, so let's wind up this session. I thought I'll take it for 35 to 45 minutes. It's exceeded one. I think it is 1 hour. Okay, let's wind up this session. Thanks. I'd like to thank everyone for attending this class, and hope you got some things out of this particular session. Okay. Yeah. Thanks everyone. Thanks a lot. Bye. Take care. Thank you so much. Thank you so much. Appreciate it.